So in number 53, we have a jet of water that's squirting out horizontally from a hole near the bottom of a tank, shown in the figure. If the hole has a diameter of 3.5 millimeters, what's the height of the water level in the tank? So we've got water squirting out the side over here, but the question is, what is that doing? Um, well, basically we have projectile motion. It leaves horizontally, and then it falls 1 meter and ends up 0.6 meters away. We can use projectile motion to actually calculate what the initial velocity of that water jet is. If you remember, the y position of any projectile is given by its initial vertical velocity times time plus 1/2 gt squared. In this case, the initial vertical velocity is just 0, and we want to know when its y position is 1 meter below where it started. Again, quick reminder, we always tend to make the initial position of any projectile the origin. And so we want to know when it ends up here, which is 1 meter below where it started. Gravity, we're going to make -10. If you solve that, we know it's going to hit the ground at t equals 0.447 seconds. And we can now use that time to figure out what the initial... Sorry, my handwriting is bad. The initial horizontal velocity. So in this case, we know the x position is 0.6. The time we just solved from just over here, and if we solve that, we know that the water is going to leave at 1.34 meters per second. I'm going to quick erase this so it gets out of the way. And now, I'm going to set h equals 0 right at the bottom of the tank. Remember, you can set the height equals 0 at any point you would like. In this case, it's just convenient because it'll make things a little bit easier. And now in this equation, I'm going to pick a point up here and the point down here. What do we know is true about the air pressure here compared to the air pressure here? They're going to be the same. And so we can cancel out these two terms. Doing that just gives us that. And now, what's the height of this second point? Well, since I defined h equals 0 right there, this term is also going to be 0. There is no height, because it's at h equals 0, for the second point, dropping that term. And now, the other question is, what's the velocity of the water over here? Now, you might say, oh, okay, I can use the equation of continuity to solve this. The problem is they gave us the diameter of the bottom hole, but they didn't give us any idea of how big this tank is. So there's no way for us to actually calculate this velocity using the equation of continuity. A1 times V1 equals A2 times V2. So I guess we're going to have to assume, and you're like, wait, how do I know this for certain? We're going to just have to make it 0, which means we're going to drop this term right here, leaving us just with this. The density of the water occurs on both sides of the equation, so I can actually divide both sides by that, giving us just this. And at this point, I'm ready to plug in my numbers. We're trying to find h. We know the final velocity is 1.34 meters per second. Plugging in gravity is 10. We can solve it and discover that the height of the water needs to be 0.04 or 0.09 meters or 9 centimeters. I hope that makes sense. Good luck.